Okay, now this is part 3 of our Math 137 online review for the final exam. We're now ready for problem 9. And now, problem 9 says plot the point given in polar coordinates. So they give us the point 4. Now this was actually on the test. If you look, it's a multiple choice problem, so it gives you 4 opportunities. But let's just figure this out. So once again, polar coordinates, it's not x and y, it's r and theta. Where r, you can think of as radius, or this is the distance, and theta is the angle. So basically, you always do your angle first. For an angle, you always start at the positive x-axis. So then where would 180 degrees be? 180 degrees is just the opposite side. So in a sense, this is going to be the direction. And how long is it? 4. So I'm going to move 4. So really my point, that right there in polar coordinates, is 180 degrees. And then just to make it simple, if you look at the test, or here this homework problem, gives you 4 choices, and you can see this is the one where it's 180 degrees, this is a 4. That's obviously the answer. Matter of fact, number 10 is almost identical. Plot the point given in polar coordinates. So once again, so it looks like r is -10, the angle is 0. Once again, you always start with your angle. Angle 0 is like this direction. And then a distance of -10, +10 would be right here, but a negative distance, a negative r, means you go just the opposite side. So if it's this direction, all of a sudden it's going to kick me over here and put me right there. So once again, it's a multiple choice question. And if you look at these choices, you'll see this is the one. The reason these look the same, but this is at -10, this is at -11. Seems pretty minor. So it's C. Wow, 3 in a row. Plot the polar coordinates. Actually, this is like the same thing as this one, except -10 you go -7. I wonder if that was a mistake. It's like a repeat question. Actually is. The same question got repeated. So there may be a chance when you actually work this out, well, I'm not going to change it now, but that's a mistake. Anyways, here's another one to plot. Actually, what I'm going to do is, because we're going to fix this, I'm going to eliminate this one from the homework. So when you actually start working on these, this next one will be problem 11. And it's another polar coordinate one, -4, 120 degrees. So you always do your direction first. So where's negative 120 degrees? We always start the positive x-axis. I know 90 is straight up. All the way across is 180. So 90 straight up, I need to go 30 more. So that's my guess of 120 degree angle. But what is my distance? Negative 4. Now positive 4 would be like maybe right here. But negative 4 tells me to go in the opposite direction. So in a sense, I think it'd be something like that. And if you actually look on the ones, you'll see it. Wow, there are lots of these plotting polar coordinates. So number 12 is, wow, another repeat. So actually, once I finish the homework, this is going to be number 12. There's the polar coordinates. -9 minus theta. Now the difference is the angle here now is in radians. So we have to now think back like in radians. So let's go find this angle. What is angle negative pi? Remember, normally positive angles means you move, start the x-axis, positive x-axis, move counterclockwise. Negative angle just means you start the positive x-axis, but you move clockwise. Now I know pi is halfway around the circle. So basically, negative pi puts me over here, sort of like the negative x-axis. But then what happens to the r? It's -9. 9 would be here, but -9 means I go back over here. And that right there will be your answer. So 13, still on polar coordinate kind of stuff. If you look at problem 13, it says plot the point, and this is given in polar coordinates. 1, 3 pi over 2. So polar coordinates. And find other polar coordinates of the point for which the following are true. Now, this is a problem. Let's go plot this. I'll explain to you what they're wanting you to do here now. Because we talked about how when you write things in polar coordinates, you can have one point have different polar coordinates. It's not that way with x and y, but it is that way with polar coordinates. So let's go plot 1, 3 pi over 2. So this is in radians. So 3 pi over 2 is 3/4 the way around the circle. And distance of 1, so we'll just say 1's right here. So that right there, that point is 1, 3 pi over 2. But now, they want us to figure out some alternate ways to get to this same point besides 1, 3 pi over 2. Matter of fact, part A says r greater than 0 which means R is going to be positive, and they want the angle theta to be between 0 and negative 2 pi. So it's almost, they're saying, okay, keep your R positive. Let's go and use a negative angle, and we want to get to this same point. So what would we do? If we're going to go negative angle, how far did I go here? Negative pi over 2, and the distance is still 1, so it looks like in polar coordinates 1 negative pi over 2 is really the same point as 1 3 pi over 2. Now for part B, they switch it up and they say, okay, now find a point. They want R to be negative, but they want the angle to be positive. So think to yourself, I got to go find a positive angle. Let me redraw it. I got to go find a positive angle, and I end up here. Positive angle and a negative R. So that means when I get my angle, the negative R is going to go in the opposite direction. So I think what I want to do is, don't I want to go here with my angle? Because this is a positive R, and then the negative R sends it here. So I think I want to go an angle of pi over 2. So here's my proposal. Negative 1 pi over 2. Let's see if this makes sense. Pi over 2 is right here, but the negative 1 causes it to go down here. I think that's correct. Then there's one more. So these are the unique thing about polar coordinates. Now I want R positive. All right, and the angle, what do they want with the angle? They want it to be between 2 pi and 4 pi. In other words, what they're doing is they're saying, make one whole trip around the unit circle and then figure things out, right? Because it's 2 pi. So in other words, this is where I want to end up right here. I'm going to first going to go 2 pi, and then how much further do I go? It's almost like 2 pi plus 3 pi over 2, which would be like 7 pi over 2. And the distance is still going to be 1, so I think, since R is positive 1, and 7 pi over 2, which is correct. All right. Let me go ahead and I have a few more problems with polar and rectangular coordinates. Let me try and finish these out in this video. So now we're ready for problem 14. The polar coordinates of a point are given. Find the rectangular coordinates. So here they give us polar coordinates. So that's r theta. And they want to know what is that in rectangular coordinates. So this is where you have the fortune of having the formula sheet. Polar and rectangular. X is r cosine theta. Y is r sine theta. Right? And they wanted exact answer, so no calculator. So let's see. So x, r is -3 times the cosine of 7 pi over 4. And y is -3 times the sine of 7 pi over 4. Let's figure out, this is where we're going to use unit circle. Where's 7 pi over 4? 7 pi over 4, I believe, is right here. So there's 7 pi over 4. Except now, since it's a -3, it's probably going to be right about here. So there it is in polar coordinates. It's always good to graph it, because now when I get my x and y, I can see if it makes sense. Cosine of 7 pi over 4, that's part of my special angles from unit circle. And I know that cosine is square root of 2 over 2, so I think when I plug it in for cosine of 7 pi over 4, I get -3 square root of 2 over 2. Now for the sine of this, the sine of 7 pi over 4 is negative square root of 2 over 2 times -3. So in x and y should be -3 square root of 2 over 2 and 3 square root of 2 over 2. X is negative, y is positive. That makes sense. That actually is the correct answer. So now number 15. The rectangular coordinates of a point. So now it gives me the x and the y, and it wants to know what would this be in polar coordinates. Now you could use your equation, but let's go ahead and plot this. 14 zeros like right here. So actually, I don't need to even use any formulas, because what would this be in polar coordinates? Well, this angle is 0, right? And the length would be 14. Looks like it'd just be 14, 0. That's sort of common sense. Now the last one, 16. The rectangular coordinates of a point are given. Find polar coordinates of the point. All right, so they give us a rectangular coordinate. If I were to graph that, always helps to graph. 6, -6. Now they say they want this in polar coordinates, but they say when you give it, they want to make sure the polar coordinate you give where r is positive and the angle is between -2 pi and 2 pi. So all we need to do is we use the other formulas from my formula sheet. If I know x and y, here's a formula to find the r and to find theta. So r x squared, 6 squared, plus y squared, -6 squared, 36 plus 36, 72, but this simplifies. 36 times 2, 6, square root of 2. So r is going to be 6 square root of 2. To find the angle, tangent of theta is y over x. Y is negative 6. X is 6. Here's where you got to be careful, because we have to take the inverse tangent of negative 1. I should be able to do this in my head. Basically, I'm saying go find an angle where the tangent is negative 1. Tangent, once again, is sine over cosine. So where are the sine and the cosine the same, except opposite sign? And that has to be in quadrants 2 and 4, where we can see we're in 4 here. So that makes sense. And this happens at the power over 4 points. So I believe this right here is 7 pi over 4. So I think my final answer, the radius is 6 square root of 2, the angle is 7 pi over 4, and that is correct. All right, so that's polar and rectangular coordinates.